Okay, here we have a little self-check for you, a little review of some basic quadratic concepts. We're going to first talk about these different forms of a quadratic equation. Vertex form tells you where do you move the bottom point of a, this part, the little vertex part. This one looks like it's moved over to the right and up a few. So this is the format right here that tells us move it 3 to the right. And this +2 on the outside of the parentheses tells us to move it up 2. Sort of how we just graphed it here. So this is what we call vertex form, right? C. Expanded form is when we multiply. So we could take x minus 3 times x minus 3, which is what x minus 3 squared means, and double distribute to get x squared minus 3x minus 3x again is minus 6x. And negative 3 times negative 3 is plus 9, plus 2 more, and I get something that looks like x squared minus 6x, put my apples with my apples, plus 11, my y-intercept, which we can sort of see is what that would be. If it kept going up, it would be pretty high. We call that expanded form, right? In this case, we have to add 2 more to it, and if I added 2 more to that, it would even be plus 13. So this, whoops, no, it was just plus 11. I added twice, didn't I? Oops. Okay, so this is expanded form right here. Ones that look like this, letter B, something squared, something x, something. Factored form is where it still looks like a multiplication problem, and usually that is going to tell us the zeros of a problem. Like in this case, we would know that one of the zeros was 0, basically telling when does 3x equal 0? And when does x minus 4 equal 0? So 0 and 4 would be the roots of this problem, 0 and 4, and we'd have some sort of parabola in the middle like that. So this is what we call factored form, A, where it's something times something else. Okay? Let's see, we know that an equation is quadratic if there is just an x term. No, that would be linear. A 2 to the power of x term, that's what we call exponential, remember? So we're looking for something that has an x squared term, or like even like these, an x times x, right? These are the ones that would make it quadratic. 3, in a table we can tell if the relationship is quadratic by finding well, we just did this in the last video. First, again, difference would be linear. The second difference is how we know it is quadratic. The second difference for the second power of 2, right? In a table, we can find the x-intercepts by looking for, so if we're looking in a table, sort of like the last one, let's just look at this graph. The zeros are where is the outputs equal to 0, right? So here, we can find the x-intercepts by looking for the value. Is it when x equals 0? This is when the y's give you 0, right? The output. So if 1 goes in, 0 comes out. If 3 goes in, 0 comes out. So we're actually looking for the value when y equals 0, right? We need some x, and then we get 0 to come out. We need some x, and we get some 0. Often there's 2, sometimes there's just 1. If you found the vertex of a parabola is 4, 5, the equation in vertex form would be, well, which one of them moves it 4 to the right? That moves it 4 to the left. And that minus 5 moves it down 5. That's not what we want. This one moves it 5 to the right. And up 4, that's not what we want. This one does move it 4 to the right and up 5. So we do want this first one, and that's why we study transformations. Almost done here, everybody. Given this equation, which values for x and y satisfy the equation? Let's just pick a few and try it, right? I'm going to start with the smallest numbers. They look easy. If x is 2, I can do 2 squared pretty quickly. In my head is 4. 4 times 3 is 12. Then I also need, if x is 2, 3 times 2 is 6. 12 plus 6 is 18 now. Minus 5, that gives me 13 for y. That is not negative 10. So that one does not work. I'm going to do that again. I'll try it with this one. If x is 3, 3 squared is 9, 9 times 3 is 27. 3 times 3 again is 9. 27 plus 9 is 36. 36 minus 5 is 31. It says that the output y is 31. So I just plugged in x equals 3 to figure out what did I get for y. I'm graphing that parabola. If 3 goes in, 31 comes out. And lastly, the solutions for this equation. Well, the easiest way I'm going to try to do this, I'm going to factor that so I know what it looks like. Let's say I'm going to put an x in the first two spots. And what two things multiply to 3? This is like a sum factor game. I want things that multiply to 3 but add to 4. So I want to get 4x. Let's see, I'm going to choose 3 and 1. So if I write x plus 1 and x plus 3, what do I get? X times x is x squared, plus 1x, plus 3x is plus 4x, and 3 times 1 is 3. Perfect. So if I want to know what the solutions are, the solutions is another word for the zeros, or the x-intercepts, or the roots. These all mean the same words, right? So let's actually say if this was equal to 0, I can even just cross off the equals y and say, when does it equal 0? And if 0 equals this times that, well, you know what? Either this first part better be 0, or the second part better be 0. And you can watch this twice, perhaps. What number plus 3 is 0 if x equals negative 3? And what number plus 1 is 0? And that would be if x equals negative 1. And we also know that if x plus 1, that implies to us that we're sliding something to the left 1. This implies we're sliding a picture to the left 3. So our roots, or our zeros, are negative 3 and negative 1.